What's poppin', dogs? Mr. Allen here with some Algebra 2 Honors Semester 2 Finals Review Guide. We're going to key this whole thing. I will break it down into module and topic, so let's get going with Module 2, Topic 2. We're going to hit some Pascal's triangle first here. So if you don't remember how that starts, we start with 1 up top, and then we got 1 and 1 for our second row. Really our kind of our first row, first power anyways. Then we got 1, 2, 1, and we're just going to add now these two, the 1 and the 2 become 3 right here, same here, and then we got 1 on the outside. We always start with 1 on the outside. We got 1, 4, we got 6, 4, 1, 1, 5, 10, 10, 5, 1, and why don't we go one more just for fun, right? We got 6, 15, 20, 15, 6, and 1. There we go. Okay. I think that's enough of Pascal's triangle, especially for what we're doing on this one, which it says to use binomial theorem or Pascal's triangle to expand that binomial. We'll go ahead and use Pascal's triangle since we have it written down. All right. Now, what I like to do is I like to give a lot of space to work with these things. We have a degree of 4, which means we are going to be focusing on this guy right here. So what I'm going to do is I'm going to write down 1, leave some space. Then I've got myself the 4. Then we have a 6, 4, and 1. And now I have room to write my other terms. Okay, so my first term here, I'll do this in green. So my first term is going to be that 4x. So 4x. And we're going to raise it to the highest power, which would be 4. And then I will write 4x again for the next one. I like to do this systematically where I work my way down with each individual term. So we got 4 to the third power, sorry, 4x to the third power, 4x to the second, 4x to the first, and then we have 4x to the 0, which that's just going to go away. So don't really have to worry about it, but I'm going to write it all out because it's a little easier to understand everything that's happening. Then we've got our second term, and you need to include that negative with it. That's very, very important. So we have negative 3y raised to the 0 power. Then we have negative 3y raised to the first. And there we have the rest of them. All right. So those odd powers with that negative 3 are going to result in the entire term being negative. So that's why I didn't put any addition or anything like that between these terms. Like I don't have a plus sign here because I don't know if it's going to be positive, it's going to be negative. We're going to work that out here in just a sec. All right. So this first one here, I have 4 to the 4th power, which is going to be 256. You can use your calculator on this. This is on the calculator portion. So there we go. We got 256 for my lead coefficient. I will change colors to a common color. So we got 256 x to the 4th. There we go. All right, so that's my first term there. The negative 3y to the 0, that's going to poof, goes away. The 1 is just the 1, all right? So now we have 4 times 4 to the 3rd times negative 3. We can just pop that in our calculator. I'm not going to do that on the screen for you. It's a little bit, little meh. So it's easier to just type this thing in. And then we got, so negative 768. So negative 768. And then we have x to the 3rd, and we have y to the 1st. So I'll just do y, right? And now for my next one, I'm just going to do 6 times 4 squared times parentheses negative 3 squared. Make sure that negative 3 is in parentheses because overall this should be positive, right? So positive 864. Then I have x squared, and I have y squared. Next one, we have, let's see here. It's going to be 4 times 4 to the 1st times negative 3 in parentheses. I like to do that. Raised to the 3rd, we get negative 432. And we got x, y to the 3rd. And then my last one here, that 4x to the 0 is just poof, it's gone. We just have negative 3 to the 4th, which is 81. Positive 81. So plus 81 y to the 4th power. And that's the entire thing. My goodness, that is awful. But not that bad. Not as bad as, say, multiplying 4x minus 3y times 4x minus 3y times 4x minus 3y times 4x minus 3y. That would be a lot, right? Okay, there we go. It's beautiful. It's fantastic and wonderful. This one here, I'm just going to work this one out. I'll give you guys the first line, but I don't think there's really a sense in me recording that whole thing here. So we're going to have our 1 for our first term. We got then 5. We've got 10, 10, 5, and 1. There we go. So those are our coefficients, and then we're going to place all the terms. So here's all my first term there, all the 2x's, raised to the 5th, 4th, 3rd, 2nd, 1st, and 0. And now I'm going to do the negative 3y's. Make sure to keep that negative with it. And again, we start with a 0 power, so negative 3y to the 0, then to the first, second, third, fourth, and fifth as we work our way up. All right, now I'd plug all these numbers, just the numbers, into your calculator first, and then deal with your exponents on your variables. And for our last one, we have negative 243y to the 5th power. So big thing here, guys, is you may have noticed that the alternating signs that we have going on, right? It goes from positive to negative to positive to negative to positive to negative. That's a good way to check your work, check yourself before you wreck yourself, right? So, but yeah, be careful with those numbers and then work with those variables. All right. We got some application now. We got Dr. Dre just dropped a new album and is tracking sales by the day using a quartic regression equation, okay? Using the regression equation, what are Dre's approximate sales on day 15? All we need to do here, guys, is just pop in 15 for our x. So we're going to have 1.231, and then we got 15 to the 4th, and then we have 3.331, and we have 15 to the 3rd, so on and so forth. So if I actually show you something with the calculator here, just in case you're doing multiple of these ever, I plugged everything here into my y equals. I'm going to hit second quit to get back to the home screen. And if I hit alpha and then trace, it brings up my vars here, and I have it in y1, so I'm going to hit enter on that. And then I can just do parentheses, type in 15, close it, and it will substitute that in and evaluate it all for me. So we get 73,966.67, so 73,967, right? 73,967 about. Beautiful, fantastic, wonderful, right? That would be our album sales. Album sales. Cool. All right, so kind of neat trick with the Y1. Again, for this one, could have just plugged it in, but if we had like multiples, then it'd be very helpful, especially if you're comparing things or doing multiple parts of the same problem. All right, for this next one here, we have what regression model would likely be best for each of the scatter plots. So here, we're going to go say linear, right? This would be like a positive linear model. This one here looks like it's following more of like a quadratic path, so we'll say quadratic. And then this one here, it's kind of looking a little bit cubic for me here, right? So this guy's linear, then we got quadratic, and then perhaps cubic would be best here. And now if it was in like a W shape or an M shape, then we could say quartic, right? And then so on and so forth. So we're just trying to really just match them there. That's not saying that it's going to necessarily be the best model, but based on these particular, scatter plots, what do we think might be best? And that would be a good estimate right there. All right, that's it for this module 2, topic 2. Pretty short one there, but that's about it for this. We'll go on to the module 2, topic 3, as you see down there in the next dope video. See you dogs later.